Here is another physics problem. Let's assume we are given this kind of problem that says two blocks of mass 3.50 kg and 8 kg are connected by a massless spring that passes over a frictionless pulley. The inclines are frictionless, and we are asked to find the magnitude of the acceleration of each block. And in the case of B, we are asked to find the tension in the spring. How can we solve this problem? First of all, before we start solving this problem, let's look at the diagram. This is the first mass, this is the first block, which has the mass of 3 kg, and this is the second one, which is 8 kg. But in this problem, we're not focusing about the angles. All we need to do is to find the magnitude of the acceleration of each of the block, and lastly, we need to find the tension of the spring. The tension is not for each of the spring, rather each of the block, rather we're focusing on the spring itself. So, to solve this problem, we can use the Newton's second law and the principle of conservation of mechanical energy. So, let's dive in. Let's donate M1. Let's call M1 to be A, and let's donate M1 to be the first mass of the block, which is 3.50 kg. And let's call M2 to be B, and let's donate it by the second block, which is 8.0 kg. What we don't have is C, which is our acceleration of both of the block, because they are connected to each other on the same spring. So we don't know the acceleration. So that is what we are asked to find. So next thing we need to do here is to apply the next Newton's second law to each of the block. We're going to apply for the first block, which is A. Then we come back and apply for the second block, which is B. For the first block, which we are given to be 3.50 kg, this is going to be M1 multiplied by the acceleration, which we need. The right hand side is going to be M2 multiplied by the gravity minus tension. For the second block, which we are given to be 8 kg, which is M2, remember it's M2, this is going to be M2 multiplied by the acceleration, but in this case, this is simply going to be the tension minus M2 multiplied by the gravity. And this is gravity, the value for the gravity are given to be 9.8 in meter per second square. Since the blocks are connected by the massless spring, the tension T in the spring is the same for the both blocks. The only thing we need to do at this point is to add the two equations together so that we can get rid out of the tension. If we are to add these two equations together, let's start with the first one. We are going to end up with M1 multiplied by acceleration plus, if we are done with this part, or coming back down to this, is going to be plus M2 also multiplied by the acceleration. At this point, we are going to get rid out of the tension. So at the right hand side, we are going to start with the first one. We are going to be left with M1 multiply that with the remaining acceleration. Remember, I think here is negative. So for us to bring back that, bring the one at the denominator here is going to be negative M2 multiplied by the acceleration there. So next thing we need to do, this is going to be M1. Since we have two common acceleration here by the left hand side, it's going to be M1 plus M2. Then we multiply the M1 and M2 by one acceleration. At the right hand side, we are going to repeat the same thing. It's going to be M1. Since we doesn't have acceleration there, it's going to be M1 multiplied by the gravity. We are going to subtract the M2, which we multiply by also gravity. So if you noticed here, what we don't have here, we have M1 3.50, M2 8, acceleration is unknown. What do you call it? That's the normal acceleration is unknown, but due to gravity is 9.8. So what we need to find is acceleration, which is A here, which lies here. So we're going to put acceleration A. Acceleration is unknown. So we're going to take our right hand side. We're going to formulate the formula for us to find acceleration. This is what we're going to use here. Acceleration is going to be what? M1. Our M1, we're going to multiply that. We're going to start with the left hand side, so the right hand side. M1 multiplied by G1. Sorry, multiplied by gravity. Then we're going to subtract that by M2, which we multiply by our gravity. Taking the one in our left hand side, which is just M1 and M2. Then at this point, we can substitute our value. When we set acceleration, what is M1? M1 is given to be 3.50 with the unit kilogram. G1 is 9.8 in meter per second square minus M2. M2 we're given here, which is 8.0 in kilogram. We're going to multiply that by 9.8. Remember the unit here is meter per second square. We're going to divide everything by M1, which is also 3.50 in kilogram. We're going to multiply that, we're going to add this addition here. We're going to add everything here by M1, M2, and the value of M2 is 8 kilogram. 8 kilogram. At this point, unit will start cancelling out. Let's say kilogram here goes with this kilogram, and this kilogram goes with this. If you multiply 3.50 by 9.8, our acceleration, and this is simply 3.50 multiplied by 9.8, this is simply going to be 34.3. And if you multiply negative 8.0 multiplied by 9.8, and this is simply going to be negative 78.4. The only unit we are going to be left with at this point is Newton. At the denominator, if you plus 3.50 by 8, you are simply going to be left with, this kilogram won't cancel out, but the kilogram here won't cancel out. The only kilogram that will cancel out is the one at the top. If you plus 3.50 by 8, we are going to be left with 11.5 in kilogram. Let's create some space. So, our acceleration, 34.3 minus 78.4. This is simply going to be negative 44.1. Remember the unit there is Newton. And denominator is still going to be 11.5 in kilogram. If you divide negative 44.1 Newton divided by 11.5, your final answer is simply going to be negative 3.8. Since it's acceleration, our unit is going to be in meter per second square. Since the acceleration is negative, it means that the block moved in opposite direction. Now we can use these values and find for T, which is tension of the spring. For us to find the tension of the spring, use either the original equation to find T. Let us use the equation for the first block. The equation for the first block is given to be T. I'm making T to be the subdirected formula because we are trying to find the tension. But the equation of the first block is T1 multiplied by G minus M1 multiplied by acceleration. The only thing I need to do at this point is to substitute my value. My T is simply going to be M1 is 3.50. You know that, which is in what? Kilogram. That's the first mass of the block multiplied by my acceleration due to gravity, which is 9.8 in meter per second square, minus the same m1, which is going to be 3.50 in kilogram also, then multiply by my acceleration. At this point, we already know the value of acceleration, which is negative 3.83 in meter per second square. At this point, if you multiply 3.50 by 9.8, then you're going to subtract that from the right hand side, 3.50 minus 3.50 multiplied by negative 3.8. At this point, we're going to be left with, if you multiply 3.50 by 9.8, you're going to end up with 34.3. Then minus is simply going to be negative, because here we have negative 3.50 multiplied by negative 3.83. This is simply going to be positive 13.4. The unit is still going to be in Newton. If you plus everything at this side, our tension of the spring is simply going to be 47.7 Newton. So the magnitude of the acceleration of each block is approximately 3.87 meter per second. That is in opposite direction. That is why we are having negative. And the tension of the spring is approximately 47.7 Newton. This is it for this problem. Thank you for watching. See you next time.